Hi, my name is Ramu Durga Prasad from VVIT University. Of the register number is 25BQ580409. Now we are talking about the basic logic gates and universal logic gates from STLD. Now we are talking about basic logic gates. Then after we are talking about universal logic gates, the secondary. The logic gates are basic building blocks of digital electronics. By using these logic gates, we build the digital electronic like circuits, full adder, half adder, etc., combination of sequence of circuits by using this basic and universal logic circuits. They perform logical operations on binary input 0 and 1. It operates on only 0 and 1. Now we have three basic logic gates. Those are AND gate, OR gate, NOT gate. We are seeing the operations of the each gate. First we are getting the AND gate. In the performance of the function of AND gate is if any one input is low, the output will be low. For example, or if any high only when inputs are high. If any one input is high, the output is if any if any one input is low, the output is also low. If two inputs are high, output is high. That means the AND gate performs into operation A into B operation. That means B equal to 1 and B equal to 0. 1 into 0 how much? 0. Zero into 0 how much? 0. 0 into 1 how much? 0. 1 into 0 how much? 0. 1 into 1? 1. In basic logic gates, we have not n two inputs, we have n number of inputs. That means n number of inputs. We have one formula for combinations. We have a 2 power n combinations. 2 power n number of inputs. We have a n number of combinations. N equal to 2. N equal to 2. We have 2 power n number of combinations. That means 2 power 2 equal to 4. If n equal to 3, we have 2 power 3 how much? 8 combinations. If you have n inputs, we have 2 power n combinations. Okay, this is all about the AND gate. And we are going to the OR gate. What is OR gate? In previous, the AND gate performs multiplication operation. In this OR gate performs plus operation, sum operator. If two inputs A and B, the output will be A sum of B. Now we see in the truth table 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, how much? 1. 1 plus 1, how much? 1. That means the function of the OR gate is if any one input is high, the output is high. The output is high if any one input is high. These are the n number of inputs and 2 power n number of combinations. This is all about the OR gate. The note point is we have only 1 and 0 operators, 1 and 0, and we have 2 operators only. That means into and plus, multiplication and sum. We use only these 2 operators only. for any gate, AND gate, OR gate, NOT gate, anything. Now we are going to the NOT gate. This NOT gate is also called an inverter. Because why we are calling this inverter? Because it inverts the input. For example, is A, input is A, output is how much? A bar. The output is opposite to the input. But means A is equal to 0. A bar, complement of A, 0 equal to how much? 1. If A equal to 1, complement of A bar equal to how much? 0. That means complements the input. We also call it the input is complemented to the the output is complemented to the input, or input is complemented to the output, anything. If you give A bar here, the output is how much? A. But the basic thing is inverter only have only one input and only one output. This not have a n number of inputs and 2 power n combinations. No, only one input and only one output. These are all about the basic logic gates. What are they? And, or, not. The AND performs multiplication operation and the OR performs sum operation, or the NOT performs complement. Which gate? NOT gate. These are all about the basic logic gates. Now we are going basic logic gate, and we have a XOR gate. That means in XOR gate, if any two inputs are same, the output is 0. That means 2 input 0 0, the output is 0. 2 input 0 0, same output is 0. In XOR gate, produce a high. The output only when one of its input, one of in inputs is high and others is low. It means if any one input is high, if two inputs are same, output is 0. It gives the exclusive OR. 0 0 0 0. That means A bar B plus B bar A equal to A B. A bar B plus B bar A equal to A plus B. This is all about the XOR gate. Now we have a XNOR gate. XNOR gate means if any odd number of ones in inputs, the output is 0. That means odd number of ones, 1 1. We have a here what? We have a even number of inputs. The output is 1. In the converter 1 1 equal to 1 0 0 equal to 1. If any odd number of ones in the truth table, the output will be 0. This is all about the XNOR gate. A and B, Y equal to A complement of B. This is XNOR gate. The XNOR gate is nothing but XOR gate but the output will be complement. What is the output of XNOR gate? A, B. If you complement the output, it is XNOR gate. This is all about the XNOR gate. What is the function? If any odd number of ones in the input, the output will be 0. If any even number of 1, the output will be 1, or even number of zeros, the output will be 1, or nothing but if say same number of inputs, the output is same number of outputs, the output is same. Now we are going in the universal logic gate. What is the meaning of universal logic gates? By using this universal logic gates, we can implement and or not any gate by using this universal logic gate. Now, so we call it as universal logic gate to build any gate. Now we are going in the AND gate. We have a two universal logic gate, AND gate and NAND gate. NAND gate and NOR gate. NAND gate is equal to NOT and AND. That means the complement is nothing but a NOT gate. The complement is what? NOT gate. That means we have a AND gate here, and this AND gate is output connected to the NOT gate. Output input A and B. Output is Y. Y equal to how much? A into B. What is the output of the AND gate? A into B. Output of the NAND gate? Complement of input A by A into B whole bar. This is NOT gate. That means 0 into 0, how much? 1. 0 into 1, 1. 1 into 0, 1. 1 into 1, 1. In AND gate, we have this is 0. This is also 0 into 0, how much? 0. 1 into 1, how much? 1. This is also 0. This is also 0. This is only 1. Is the complement of AND gate. So 0 how much? 1. 0 how much? 1. Complement of 0, complement of 0, complement of 0, complement of 1. This is about NAND gate. Now we are going to the NOR gate. The NOR gate is nothing but a NOT and OR gate. Complement of OR gate. In the function of the NOR gate means if any one input is high, output is low. What is the function of the OR gate? If any one input is high, output is high. Understand? The complement of OR gate. Exactly. Now you have a inputs A and B. Output is how much? A plus B whole bar. Note this bubble is nothing but a NOT gate. This bubble is nothing but a NOT gate. The complement of OR gate is equal to the NOR gate. If 0 and 0, output is 1. In OR gate, how much the output is? 0 plus 0, 0 in OR gate. Note this, in OR gate output is this. If what is the OR gate input? 1 plus 0 is how much? 1. Complement to the complement of OR gate. How much? 0. If 0 plus 1, how much in OR gate? 1. Complement of OR gate? 0. 1 plus 1, how much? 1. Complement of OR gate is 0. This is all about the NOR gate and uses of universal gate. How many types of universal gates? And NAND and NOR. What is the basic logic gates? And, OR, NOT, XOR, XNOR. Okay. What is the universal logic gates? We can use construct other basic gates. We are talking about previously. By using NAND gate, we can implement NOT gate. By using NAND gate, we can implement AND gate. By using NAND gate, we can implement OR gate. What is the three gates? Basic logic gates. Same as like by using NOR gate, we can implement three basic logic gates and XOR gates and XNOR gates also. See the circuit diagrams or logic diagrams. What is this? NAND gate symbol. Basic logic gates by using NAND gate. If A and B, output is how much? A and B whole bar. NAND gate. What is this? Is a NAND gate, and we are implement the NAND gate. Implement the AND gate by using NAND gate. What is this? A and B. Output of NAND gate is how much? AB whole bar. When you give this output to the input of this is nothing but a inverter. Nothing will act like a inverter because we can join the two inputs also. When you giving A into B whole bar is giving to the NAND gate, then it gives AB A into B, A into B, output of the AND gate. And we using OR gate. Implementing OR gate is so much. When you join the two inputs of an NAND gate, it is nothing but a house like NOT gate. It is nothing but a NOT gate. You see, NOT gate. NOT gate. We give A and B to the NAND gate. It gives A bar and B bar. It works like a NOT gate. When you give these two bars to the NAND gate, it gives A plus B. You have a Boolean algebraic functions like A plus A bar plus B bar whole bar is equal to the A plus B. Sorry, it's nothing but A plus into multiplication operator. A bar into B bar whole bar equal to A plus B. This is Boolean algebraic function. From this, we can get this A plus B answer. Now we are implementing NOR gates. This is all AND gate. By using AND gate, now we are using NOR gate. We are using NOR gate from the NAND gate. That means A bar, B bar and A plus B. What is the output of the NOR gate? Complement of OR gate, right? Now, so we use this NOT gate like NAND gate like a NOT gate. You can come A plus B whole bar. Okay, this is the NOR gate by using NAND gate. Buffer. We are talking about the buffer in previous. It not changes the output. If input is A, output is also A. We give complement and again complement A. A gives to the NAND gate comes A bar and A bar gives to the NAND gate comes A. Buffer is not changes the input. It gives as like a input of the output. Now we are talking about the exclusive OR gate. Okay, the A gate is given to the what is the output is here. Output is here how much? A into B. A into B whole bar. The A into B whole bar gives to the two NAND gate and give A bar here and B bar here. The output is how much? Exclusive gate A plus A bar plus A bar B plus B bar A. This is the exclusive NOR gate. We are using another gate here, another NOT gate like here. The output is comes as exclusive NOR gate. This is all about the NAND gate by generating the all gates. NAND, NOR, AND, OR, NOT exclusive, XOR, XNOR, NOT inverter, etc. Now we are generating the basic gates using NOR gate. What is the function of NOR gate? It gives complement of A plus B whole bar output. By using OR gate, we can use another gate here by using NOT gate. If you join the both OR gates, it acts as a NOT gate. In AND gate or also NOR gate also. We join the both inputs and output is complement of input. Now we add the NOT gate here, so it comes as A plus B. Bar cancel, so it comes A plus B OR gate function. NAND gate A bar output how much? A bar. B output how much? B bar. Now A bar and B bar gives to the NOR gate. It gives A into B. We have a basic A bar plus B bar whole bar equal to A into B. And get output A into B. This is a Boolean algebraic function. Now a NAND gate. What is the output of the NAND gate? Complement of AND gate. So we use another NOT gate here. So it comes as NAND gate. A into B complement. A into B whole bar. Buffer. What is the operation of the buffer? It gives same input at the output. No changing input at the output. This is buffer NOT gate plus NOT gate equal to A. Now using exclusive OR gate. You see here, what is the output of here? A plus B whole bar. What is the output here? A into B. AND gate and NOR gate. These both are given to the exclusive OR gate. Both are given to the another NAND gate or NOR gate. Comes as a exclusive OR gate. What is the output? A bar B plus sorry, A bar B plus B bar A. Same as the exclusive NOR gate. We use another gate here. Another NOT gate here. Comes bar. This is about exclusive NOR gate and exclusive OR gate. Now we are building the OR gates by using the NOR gate. Finally, it comes to conclusion. What we are discussing about previous basic gates and OR NOT and universal gates NAND NOR. And universal gates are extremely important to say the complementary digital circuit. And how to implement the all other gates by using this NAND and NOR gate. Thank you.